Now what you see on the screen is the most balanced sphere of the world. Thousands of working hours and 10 million euros have been spent on it. In this, the silicon-28 isotope of silicon is used. Now your question is, why so much money and labor was spent on this useless thing? kg or kilogram is the reason for making this beautiful polished, balanced sphere. In 1793, Anthony Levasseur defined the first unit of mass. According to his definition, the mass of water in a volume of 1 cubic decimeter at freezing or 0 degrees Celsius temperature is employed as unit of mass and named grave. But then some people think that grave's value is too big, a unit to measure anything. As a result, grave was replaced by gram. But within a few days, they realized that gram was a very small unit. As a result, they come back to the grave unit. But this time, the name grave was changed to kilogram, which is equal to 1000 grams. This is why the prefix kilo is used only with the SI unit kilogram. Then 1799, the definition of kilogram was slightly changed. There, instead of 0 degrees Celsius, the temperature is set at 4 degrees Celsius. Because at 4 degrees Celsius, water has the highest density. However, the use of water as a unit of mass was not very convenient. A pure platinum cylinder was therefore constructed which had a mass equal to the mass of a cubic decimeter volume of water at 4 degrees Celsius. And the platinum cylinder is declared as a unit of mass or kilogram. After 19 years, in 1889, the platinum cylinder was abolished and brought a new cylinder made of platinum and iridium. Since then, the definition of the kilogram has been this cylinder made of platinum and iridium. It is the only exact 1 kilogram in the entire world because it is the kilogram itself. It is the only SI unit defined by a physical object. This cylinder is enclosed in a protective glass container and a vault with 6 more identical cylinders locked inside, and the vault's environment is fully controlled. The vault is secured with 3 locks, each with a key held by a different person. Interestingly, if you are able to gain access to the cylinder inside the vault, you have the ability to change the definition of a kilogram. Because this cylinder itself is 1 kg, so any change in that would actually change the definition of the kilogram. So you could create an unusual mess in the whole world's calculations. Now the question is, how will people know if the mass of the cylinder kept in the vault is correct or changing? When the cylinder was first produced, 40 identical replicas were made, and those 40 replicas were sent to different countries for use as their national standards. Later, in 1984, all the replicas were put together. A problem then became apparent. All the replicas were made of the same material and kept in the same environment. But over time, there was a substantial difference in the mass of these replicas. Now the question is, how much mass has changed? It was found that their mass had changed by 50 micrograms over 40 years. These 50 micrograms, though not very much, is equal to the mass of an eyelid. Although this difference is very small, the problem is that platinum and iridium are not stable. So the mass of this standard cylinder in kilograms will change with time, and that is the main problem. Because we have a unit that is itself changing value over time. Also 4 of the 70 SI units depend on this unit of mass. Now if this unit of mass itself changes, then the other units will also change. One thing that makes it very clear is changing the dependence of the kilogram on the physical object. And from this necessity arose the roundest, balanced sphere on Earth. This sphere contains only the silicon-28 isotope. Separating this isotope was very difficult, and the silicon-28 isotope was separated using a centrifuge method, and it is 100% silicon-28 isotope. This sphere was initially 2 mm larger in diameter than its present size. It is then very carefully polished to bring it to its current shape, the mass of which is exactly 1 kilogram. When a question comes to mind very naturally, instead of a physical object, one more physical object, then the previous problem will remain. Guys, the interesting thing here is that since this sphere is perfectly symmetrical, if we can measure its diameter, then we can calculate the exact volume of this sphere from the diameter. And if we find out the exact volume, we will know how many silicon atoms are in this sphere. The diameter of this sphere is measured by laser. Then the volume is determined from the diameter and the atomic number is calculated from that volume. And calculated, it contains 2.15 into 10 to the power 25 silicon atoms. Now we don't have to rely on a cylinder in a vault for units of mass. Now, if someone tells you what a kilogram or 1 kilogram is, you can easily say that the mass of 2.15 into 10 to the power 25 atoms of the isotope silicon-28 is 1 kilogram. However, this is not the only attempt to remove the dependence of the unit of mass on the physical object. There, the kilogram is defined by Planck's constant. The definition of the kilogram with the Planck constant came out in November 2018. On 20 May 2019, the new definition of the kilogram was adopted internationally by a vote of all countries. Now the question is, what is this new definition of kilograms? The only way to remove dependence on physical object is to depend on something natural. Scientists then choose Planck's constant because we know Planck's constant is a constant used to measure the energy of photon, or E equal to hf. Here E is energy, h is Planck's constant, and f is frequency. Also, Einstein has another popular formula which is equal to mc square. Now if we put these two parts together, then we get m equal to hf by c square. Then it appears that mass can be nicely defined by Planck's constant. But the problem here is the Planck constant itself. Because the exact volume of the Planck constant was not known, Planck's constant had a problem with some digits after the decimal point. Therefore, to define a kilogram correctly, it was first necessary to know as accurate a value of Planck constant as possible. That's why scientists use a method called kibble balance. This method balances the mass with the electromagnetic force to determine Planck's constant. Although the technique is much more complicated. However, this is the value they ultimately get for the Planck constant. Then we get a fixed value of Planck constant. So other units of SI units that are hanging on mass are now fixed. Now we can explain the kilogram in two ways, the balanced sphere and the Planck constant. And therefore ended 129 years of dependence on cylinders kept in Paris. So the Paris cylinder is no longer needed. That does not mean that the cylinder will be thrown away, but will remain under tight security as before. Friends, if you enjoyed the video, you can subscribe to the channel.